Hello. I'm back. There's a video on the blog right above me, should be like right there, that has Nemo and a whole bunch of fish in a net doing stuff, exploring physics. I want to talk about that, give you a little bit of help. So, first, let's draw a picture of what was going on. There's a big net, and inside this net were a whole bunch of fish. Since we don't have all day, I'm just going to draw a few. We had one fish that was going this way, one that was going down. He kind of got out of the net a little bit. One going to our left, and then one going up. And what Nemo tells them is that they're all working against each other. They're basically having a big tug of war where this fish and this fish cancel each other out. And this fish cancel each other out. So the net force, which is a term we're going to use, that means all the forces acting on an object, in this case the net, cancel out. There's no net force in this problem. It's almost like there's no fish in it, or the fish are doing no work at all. Now if we change this a little bit, and in the second part, this is what Nemo tells them to do. We draw our net again, but this time, we ask all four fish to swim down. Now we're going to have a net force going down, where all of these guys are helping to pull the net down. Imagine in these two situations, a tug of war where it's one on one, going opposite direction, versus another tug of war, where you have four people on one end of the rope just pulling it one direction. It's no contest. Here there is a net force. Here there's not. But these pictures are a little confusing, so we're going to draw them again in what we're going to call a free body diagram, or FBD. A free body diagram is very simple. It's a diagram that is free of bodies. There's no bodies in it. So let's take these fish and let's get them out of there. I'm going to draw the net and the fish again. Ready? Done. It's just a dot. Very simple. We have one fish going to the right, one going to the left, one going up, and one going down. Let's assume that every single one of these fish push with the same amount of force, and we'll call that 1 Newton. Well, right now we have the force of 1 Newton going up, and the force of 1 Newton to the right, force of 1 Newton to the left, and a force of 1 Newton down. Well, forces are vectors. If I was to put you on the roof of the building and push you, you'd really care about direction. So direction is part of forces. If I have two forces in opposite directions, they have an opposite effect. We can add these up just like we've added other vectors up. But since we have a whole bunch of them, I'm going to make a little table to simplify it. That look familiar? Let's put all of our x's on one side, all of our y's on the other side. So these two forces go in our x column. 1 Newton for the one going to the right, and if we're calling that positive 1 Newton, then this one better be negative 1 Newton. In the y direction, we have one going up, we'll call that a positive 1, and one going down, negative 1. In this situation, we have 0 newtons in the x direction and 0 newtons in the y direction, so we have 0 net force. These four fish pushing in opposite directions cancel each other out. It's like they're not even there. In our other problem, let's first draw our free body diagram. Pretty good, huh? We have four fish pulling down again. Well, I have one going down, 2, 3, 4. Now we make our table up. X, Y, and all of these are going down in the y direction. So I have 4 negative 1 Newton forces in my y direction. So in total, I have a negative 4 Newton force. My net force, F net, is -4 newtons. Since there is a force acting on the net, it does accelerate, and in this case it accelerates down. In fact, if we knew how much mass was in this net, we could tell you how much. Let's say each one of these fish is 2 kilograms. That's about 4.4 pounds, so they're big fish. If we had 4 of them, we'd have 8 kilograms of mass. Well, my net force, according to Newton's second law, should make a mass accelerate. If I know my force is 4 and my mass is 8, then my acceleration should be 1/2. So these fish are going to accelerate down at 1/2 meter per second squared. That is a net force. Hope this helped. I'll see you guys in class. Bye-bye. Bye-bye. Bye.